Today I am going to explain structural failures of steel structures. And first of all, I'm going to explain the common types of failures in a steel structure. These are all the common types of steel structures. First of all, I'm going to explain what is mean by steel uh, structure. Means structural elements designed and other structures to resist a wide variety of forces. The different types of forces include the mass of contents of the structure, including the structure itself. Transit the forces of from the occupy of the structure, that is, people moving inside the structure, equipment operating inside the structure. Environmental forces such as wind and earthquake, snow and rain, etc. These certain structures may be required to withstand impact of forces such as from missiles or ballast. This structure which is including what is we can say that structure which are where we constructed that or the use for this, and this, the people which are the structure which may occupy the forces which inside the structure or are occupying inside the structure. This is the meaning of this steel structure simply. And it's also has some forces like wind, earthquake and snow, rain also. And steel has evolved over the 100 plus years to be widely used material in structures. The availability, economy, and strength to weight ratio and elasticity and are just few factors that may steel popular building material. These steel structures are involved over 100 years plus years, and this we have that widely. These steel structures widely used in the any overall the world, and this having the economically and its availability and having the high strength by to the ratio of the weight, and it's having the just steel has the making steel has makes such a proper by building material also. And it still does have several disadvantages must be taken in consideration while designing the structure. In this we have going to explain what the disadvantages and what the failures we see in the steel structure by the practically. I'm going to explain a few limitations. Steel has inspected to corrosion, reduction in strength when exposed to the temperatures normally encoded in the most fires, susceptibility to fatigue and cycle load and susceptible to buckling and when under compression and frictional stresses. Under the buckling only we mainly main the cause for the steel structure, and also for under in the consideration is the high compression we taken under the buckling, and also frictional stresses. This is the most steel types of failures we commonly we seen it: shear failure, frictional failure and compression failure, tension failure. These are the four types commonly we'll see in the failures. And first of all, I'm going to explain shear failure. Shear failure is typically occur in connecting connections between numbers, member which is nothing but column connection, member to guider connection, etc. Designing a connection, it's not a task, easy task. Connections typically have the having shear forces, and engineer must consider when the designing in the concession connection. Designing of a connection is not a task, but connections is the most. Here the task is what connections is the most consideration for the designing in the connection. A failure can occur in the structural engineering under which the design force and connection is to be withstand. Common connections in the steel is made by the bolts or welds. Both or combination of the bolts and the welds or connections are used in the steel structure. Frictional failure, which is nothing but uh, grinders, and in some cases compression members such as columns or be considered subject to the bending stresses. In the steel shear failure we consider only the joints which will be made by the bolts or welds. In the frictional failure we considering as in the compression members which is such that come we can say columns is the best example for the compression members, and it's subjected to the bending stresses. And simply, and in that element we may mostly we cause in the flexural member flexural failure, which we can say that column only we can cause mostly. And in that we have the element causing the buckling is the most important term which cause the flexural failure. Because steel isn't strong, uh, steel members are designed to be slim and effect, which may put the risk of buckling. So that reason only steel members and we have the slim and but with efficiency but risk of the buckling. Heavier stocky members are less susceptibility to buckling. And another point for the flexural layers creates a tension and the compression forces in the members. Lateral torsion buckling occurs with high compression forces, causes unrestrained section of member to buckling and lateral displace. Providing a lateral restraint to members, which helps the ensuring, we can say that in longitudinal, which is nothing but column having the, for example, I'm telling about column is a thin member, or we can say length in longitudinal wise. Longitudinal wise is nothing but lengthwise we have the more length, and we considered as and breadthwise it is less. In that we have to take an as in lateral also, which is not in the breadthwise also we can cause an a torsional buckling. Means that by providing the buckling, what we can say, by failure of the buckling, we can providing the lateral, we can say the breadthwise we providing the, what we can say, breadthwise we providing the strength of the material, we can say that, so that we can decreasing the buckling also in that condition. And next one, compression failures. Third one is on compression failure. Compression failure typically occur in the compression failure such as columns and braces. Within that, compressive axial force applied to the element curves the element to their buckling or become overstressed. Similarly, that fracture and this compression failures only. Similar to the beams, columns and braces are subject to high compressive stresses and may experience the buckling also. Consideration, in take to account while designing a column, it's designing of all we consider as a slenderest ratio. We can say that ratio of cross-sectional geometry to the length of the member. When a member is with high slenderest ratio is more susceptible to buckling, lower than the lower ratio. With low slenderest ratio may still fail the compressive stresses extended the material strength of the member. And next one is on tension failures. Tension failures generally occur in an braces or an angers. This type of failures when the steel member is stretched into a level that exceeds the material strength of material member. This occurs in the stages. The first beginning yielding, necking, and the material fails at the point with the least section area. Simply, we can say that steel is a very strong material and very reliable in structure construction of buildings. It is an effectuous, however, it is granted when the steel is properly designed with stand of imposed forces. Poor design is can be laid at the above mentioned failures of the, we can say that, or any compression tension or flexure or buckling failure, we can say that. And structural effect of corrosion is also a main effect for this, for the corrosion. Corrosion of the steel is often investigated in the content of durability performance of the structure. However, corrosion is equal impact of performance. Steel corrosion may result in the reducing the flexure capacity. We can say the simply loss of removable cross section, reduced bond, and limited ductility. In the article, we we review some of most important effects of the steel corrosion and structural performance of reinforced concrete elements. In that, what is a steel corrosion? First of all, I am going to explain what is a steel corrosion. Corrosion is a chemical process in which refined materials such as steel revert back of their low energy, more natural and stable state of ore. We can say that iron oxide. The phenomena sufficiently explained with the law of entropy. The reaction happens with the losing steel material and producing a red rust, and is generally 4 to 7 times larger in volume. The increasing in the steel volume increasing the stresses in concrete to contact that crack, resulting in the delamination in the concrete bridge decks or parking slabs, and loss of concrete cover in the beams, grinders, and the columns. And the structural effects of the corrosion is on first one is on loss of strength. Steel corrosion reduces the effective cross section of the structural components. This reduces the cross section with reducing the capacity of concrete elements such as slabs and beams. Wherever is the corrosion, which is nothing but where is the steel, wherever is the, we can say that in the picture is showing that, no, this is the steel rods. We can see that where that we can see the Corrosion and mainly loss of section strength can crucial in bridge decks and parking garages slabs. A major concern is that corrosion of steel component we have the bars, beams, strands does not always visual sign, which makes the inspection process very difficult. This collapse of a logo central mall is an example for of losing and capacity and integrity structural elements such that remained unnoticed during the visual inspections, which is nothing but in the, for example, in this great example for that logo center malus occurred in that they did not know, they did not inspection for this, they did not what we can say visualize this what they are doing or not unnoticed, or steel structure is not how the steel structure what beams in the columns what the corrosion occurred also they did not know that the corrosion of the steel elements covered by insulations or wire, fireproofing materials is major concern in the refinings, industrial plants and pipelines also. And next one I'm going to explain steel elements covered under the fireproofing insulation explain corrosion is on service life. Another example, famous example, is the reduced fixture and the capacity of RC element dealt at Duet all 2005 was developed a mathematical model of residual area and the formula parameter such the formula is described in the residual area based on the corrosion rate of steel bars. And corrosion take reduced the effective cross sectional area and transfers in the beams, and this is the picture is showing in that calculation of the corrosion that this is the bars, this is the depth and b, and this is the area for that, and simply and this is the 0.45 f dash the some, and t is the tension in this direction we occur it, and this is the compression zone we can occur in the steel bars we provided in this in the picture is showing a single reinforced concrete. This is the formula for the mu, which is nothing but moment of resistance. A is and steel area of a steel in the picture is showing, and T into and see that T by and B minus A by 5, which is the formula for that. And next one fatigue. This is another corrosion form effect, and fatigue is nothing but connections and RC elements. Corrosion may accelerate fatigue crack propagation in steels. Development of putting and the pitting a correction, which is nothing but form the holes and introducing the additional points of steel concentration which may crack develop, which will reduce the fatigue strength. Study the effect of corrosion on how high, low and cyclic fatigue and reinforcing. And this is the study effect of corrosion. Wilson height, height L the behavior of the reinforced concrete means they conclude that corrosion of a steel markedly affects the fatigue performance of RC beams. As the mass loss percentage as corroded steel reinforcement increases, and that fatigue life of the beam is also decreases. And third one is a reduced steel concrete bond. This is the composition of the RC elements and is depend upon the characteristics of a concrete rebar interference. And when the steel corrodes, the products of corrosion expanded. We can simply say that we leave a poor quality of a steel layer over the surface of the reinforcement. This layer of poor bond will surround the concrete. Therefore, it will reduce the capacity of a section. When we consider as an let example, we taken as a poor quality of a steel. In that, we bond. We can say poor. We can bond the poor bond of the surrounding the chuttu surrounding. We can say that simply concrete. Therefore, it reduces a section. In the case of lap spacing of our anchorage, they reduce the effective length of anchorage. Simply, we can say that hooks, or we can say hooks 180 degrees or 180 degrees, 45 degrees, and 135 degrees, 90 degrees. We have the simply hooks in that it may reduce the effective length. So that and the premature failures of sections. And the study the effect of corrosion on the bond strength in RC elements is in an year of 1997 in Statist. And limited ductility. The fourth point is the last one. Corrosion can scientifically reduce the ductility of a RC sections also. This is the critical in seismic design and evaluation. And corroded sections have lower ductility, which means that plastic deformation is limited. This will affect the seismic response of elements, and that corrosion enforcement in lab facils, which is nothing but not having a bar. Simply, if the suppose the length of the slab is having a 20 meters, but we have available in only 16 meters of a bar. So by using that another bar, we have the lapping and switch number by one bar to another bar, which is connected simply. That is the meaning of large spaces will affect the load transfer in the labs, preventing to the develop yield stress. And by using this lab space also is a one of the corrosion by preventing in it, and studied the seismic response corridor bridge columns by the nonlinear Purvish analysis. And how to evaluate the corrosion in the concrete, the picture is showing. While there is no prevent of corrosion from happening, there is methods of certain development protecting the maintained reinforced concrete elements using corrosion inhibited cathodic protection. And these are some protections we have in that by using the corrosion. And epox coatings has proven that effective in managing rate of corrosion. However, proper inspection, monitoring the RC elements is the key, preserving the durability and structural performance over a time. Off-cell corrosion potentially mapping, and off-cell corrosion potential is mapping an effective producer, and likelihood of effective active corrosion in RC elements. The test mostly used in the concrete bridge decks and parking garage structures also. And uh, next one where the how to have out we can see the corrosion is affected. And second step is surface electrical resistance is the cost effective and rapid non-destructive test and evaluating the durability performance of concrete materials. The test can be used essential permeability of concrete against the increase of aggressive agents such as chloride. Electrical resistance test made adapted by the these are small tests. We have the Torel D dots MT and the WSHOT TP95. This is a small test, we have seen it. And next one, third one is on ground penetrating radar, which is simply we can say the GPR, as proven as a non-destructive test method for rapiding the screen. This mainly used for the bridge decks and the garage, mainly bridge decks దగ్గర and simply in the garage slabs. Mostly we see the corrosion in that cases only. And uh, another one is the while GPR is not showing the corrosion directly, it can a lot of experiences users with identify areas with bigger likelihood of corrosion. And another why the reasons for the steel bars, we can see that when the concrete members are poor of concrete cover, when the water leakage is there, when the pattern racks due to the other reasons also, when that ductiles in the building also in the concrete member, simply we can say the column, when the building is an effective concrete paling looser plaster ceilings also, when the steel reinforcement is exposed to the corrosion environmentals, simply we can say that water or simply or any air or any we have the presence of water in the moisture in that because the corrosion. Inadaptive waterproof on a terrace, toilets, balconies, subjects, joints, etc. And above situations, we can say increasing the rate of corrosion causing the spalling. Cracks or deterioration using the service life with ultimate leads to the building failure. And thank you and for giving this opportunity. So